In today's video, we're going to be taking a look at how you can create a multiple linear regression within Python with the help of the Scikit-Learn library. Now, what essentially differentiates a multiple linear regression from a simple? Well, in fact, there's going to be multiple independent variables, also known as features, that outcome the dependent variable. And in this video, I'm going to show you an example within the sport of baseball. There's going to be many factors that determine how many wins a baseball team actually has at the very end of the season. So you can take a look at things from the batter's perspective, such as like a team's aggregate total of hits, doubles, triples, or home runs, or you could even take a look at from the pitcher's perspective, right? What's the team ERA or the WHIP, or how many strikeouts or walks does the pitcher or the pitching staff in general have at the end of the season? Now the formula is going to be a little bit different. Our simple is typically going to be y equals mx plus b. Again, very, very basic. But with a multiple, it's going to be something like y equals m1 x1 plus m2 x2 plus m3 x3. It can continue to go on depending on how many variables you use, all the way up to the very end, which you do plus b, which is going to be your intercept. Hope that isn't too confusing. It's going to be pretty simple once you see how this code specifically works. Now I'm going to jump on my Jupyter notebook right now and code this with you guys. All right, let's get started. So the first thing that you want to do is import in a few different libraries. We're going to start with importing in pandas as PD, shift and enter, runs a cell above, creates a brand new one down below. And then we're going to import random, and then we're going to import numpy as np. And we're going to use random and numpy essentially for our data creation. So I'll show you how we're going to do this. I generated this code with ChatGPT, and that way you guys don't have to download any CSVs and shouldn't have any issues recreating what I do in this video. So let's start off with that. So we're just going to put data equals to, and we're going to essentially put 2 like this, right? And then we're going to say for blank in range of 500, right? And then we're going to start building out our different columns in this future data frame. I say future, but it's not a data frame yet. So we're going to have team name first, right? And then we're going to say that's F, and put this team. And you don't need to know specifically how all this code works for this video, because this video is more based around multiple linear regressions than it is essentially building out a random data frame. But hopefully this does help that side of things. And we're going to move that over here. We're going to say season rand int 2010 2023. Then we're going to say wins plus random and int. We're going to say 50 through 110. And let me just explain real quick what these randoms are going to do is essentially assign anything from like this one is 2010 through 2023 or 50 through 110. So you have like a season for baseball team, the number of wins. Then we're going to take a look at losses, which is just right 162 if you're familiar with baseball, minus the wins over here. We're going to do hits equals random rand int. We're doing 1200 through 1600. We're going to do doubles equals random that rand int, say 200 through 350. Then we're going to say triples equals random that rand int 10 through 40, and then 2 more, and then essentially we're going to be pretty much done with these. Say home runs equals random rand int, say 100 through 250. And then lastly, strikeouts equals random rand int 1000 through 1500. Okay. Now we're going to do a few different adjustments to this data frame. That way we can actually have a kind of a linear model based around what's happening over here. Otherwise it'd be truly random and you're not going to really have good results with that. So I'm just going to say hits adjusted equals hits plus wins minus 80 times 5. Okay. Then doubles adjusted equals doubles plus, we'll just copy this over here. We're going to times it by 2 this time. Then we're going to do triples adjusted equals triples plus, and that's just going to be wins minus 80. And lastly, what we're going to do, well, we have 2 more. Home runs adjusted equals home runs. And then we're going to just copy this. And this over here for doubles should be a 2, not a 3. And lastly, we're going to do strikeouts. Score adjusted equal strikeouts. And this is going to be minus, we're going to multiply this by 10. Okay. And now we're going to have to append it some data. So we're going to say data.append. Again, any of this is confusing, don't worry about it because literally we're just going to use this for our data in this video. Feel free to skip ahead if you have your own CSV that you want to try this out on, and no worries on that. But this is kind of fun. It's adjusted and just copy all these, right? Doubles adjusted, triples adjusted, home runs, and then strikeouts. Again, also all generated from ChatGPT. Okay. So now that is over here, which is good. And shift and enter, and hopefully this works with no errors. Now we have to define essentially our column names. So we're just say columns equal, and then we'll put over here like team, season, wins, losses, hits, doubles, triples, home runs, which can be in quotes, home runs, strikeouts like that. And lastly, let's create our data frame. So df equals pd.dataFrame, throw in our data, and columns equal columns. And just to reiterate, you don't need to know any of this right here. This data, I mean, you should know how to create columns and essentially build this into a data frame, but right here, a little bit more complicated stuff, and just again, creating the data that we're going to be using. Now, just to show you what this essentially looks like, little pandas practice. df.head, right? We have our team, so team H, U, J, B, D, seasons, wins, losses, hits, doubles, triples, home runs, and also strikeouts. Now, let's take a look at what just a very basic plot would be. And you're going to import 2 more libraries, Seaborn as SNS, and then import matplotlib.pyplot as PLT. Now, you don't need background knowledge on both of these for this video again, but I think it is helpful and you should know at least the basics of plotting. You can use ChatGPT and you can create a lot of different charts, but at least having the fundamentals does help. And what we're going to be plotting is hits and wins, and then just data equals df. And again, a full video on Seaborn if you do want to check that out. Not matplotlib yet, but it will be in the future. And there we go. Okay, so you can see it's a linear relationship, right? As hits go up for a team in general, it's expected they win more games. And there's not many teams that win 110 games. Again, just random data that I generated, right? But you can see that linear relationship over here. And I also want to show you that a negative linear relationship between two different variables. So SNS.lm plot, we're going to throw in over here our x equals strikeouts, y equals wins, data equals df, and then we'll just do plot.show again. And you can see that there's a negative relationship between strikeouts and also wins. In baseball, this is kind of changing a little bit. It probably isn't as dramatic as a line of this is with strikeouts and also wins. But for the video, again, random generated, and also why not, right? We need some practice. So, okay. With that being said, we have our original data frame over here, DF. Let's get into our multiple linear regression. Now, if you're familiar with running different models in Scikit-Learn, we got to drop some categorical data. And over here, we have our team name. We don't need the team name. A team name should not impact essentially how many wins the team has in a season. Also, at the same time, I don't really think we need the season. Now, baseball had a shortened season because of COVID. This data does not really factor that into it. So it's really not necessary on that side of things. And then I don't think we really need losses. So just some good practice to dropping some columns. I do apologize if you coded those up over there, but it's good practice, right? So let's drop those first. We'll just build a new data frame, df2, and we'll just put over here df.drop. You put over here columns equal to, and then just throw them in over here. So first name is going to be team, and you're going to have over here season, right? And lastly, we're going to put over here losses, and then we'll put axis equals 1. And guess what? If we go over here to df2.head, look, we have now wins, hits, doubles, triples, home runs, and strikeouts, which is great. And I'm going to also do one thing because we're going to start splitting our data between our X and also our Y. I'll explain that in a second. But I'm just going to put over here df2.columns, and it's going to be make this much easier for me just to copy over stuff. So we have all these over here, and let's split up our data. So essentially, if you're familiar with some machine learning models, we need to have our X and then also our Y. So essentially what our X is going to impact our Y. So hits, doubles, triples, home runs, and strikeouts, that's all going to impact the amount of wins that a team has in a season. And again, I know baseball, there's a lot more things to look at than this. It's very simplistic, but I just wanted to make it easy for you guys in this video. So we're going to set our X to hits, doubles, triples, home runs, and strikeouts. And our Y, which is often known as a target, is going to be our wins. So let's split up this data frame with that. So first, we're going to say X equals DF, and then let's just copy essentially all of this over here and just throw it in. And what's kind of nice is when you put columns, already single quotes and commas, so it can save you some time, right? And then Y, I'm just going to say is going to be equals a DF, and we're just going to put our wins over here. That's our other column. So now our X is everything else, our Y, so we're good, right? And before we run our linear regression, we still have another step that needs to be taken place. We need to split up our data again. So we're going to split up our data into a training set and then also a testing set. And that's done through something called a train test split. Essentially, you don't want to train all your data on the full set that is available out there. You want to have some of it just for training and then some of it for testing purposes. So let's do that. So the first thing we're going to have to do is from sklearn.model _ selection import train test splits. So now that is imported in. And by the way, again, if you're brand new to Scikit-Learn, which some of you are, some of you have been watching all the categorical stuff, you'll learn really fast, like where to look these things up. Like I still look up essentially where all the different libraries are within Scikit-Learn, and I'm sure it'll ingrain my memory over time. But it just takes 2 seconds to research like train test split. You Google search on Scikit, and then you essentially get this code that you can put in over here. So just a little bit of tidbit, because I know we have imported quite a lot of different libraries, and if you've seen some of the other Kaggle projects, there's way more in there. I don't memorize those. I just Google search them and throw them in. So, okay. A little bit tangent there. Now we're going to do X train. We're going to do our X tests, which if I can type correctly, we're going to do our Y train and then Y test. We're going to say that's equal to train test splits X, Y test size equals 0.2. And we'll do a random state equals, and then we're going to put in Miguel Cabrera's number. He just retired essentially today. I'm going to look it up, and it's kind of embarrassing. I think it's 24, but I could be wrong. It is number 24. See, I should have went with my judgment. But we're going to put that over here. Miguel Cabrera, watched him a lot when I was growing up playing baseball. So, okay. Random state 24, test size 0.2. One other thing to call out too is when you build out your models, you're going to see normally capital X, lowercase y. Make sure you do that. It's kind of standard practice. It will work if you have lowercase x or also uppercase y, but everything that you see online, capital X, lowercase y. So make sure to kind of ingrain that. Essentially what we're doing with this over here, we have our train and our test, right? Y train, Y test. We split it up over here. Our test size is 20%. So 20% of our data is testing set. 80% is going to be our training set. And then random states, that way you guys can copy and get the same exact results I have. So, okay. Now that is essentially built in over here, we can work on our linear regression. Let's bring in our linear regression. So from Scikit-Learn.linear model, import in linear regression. Okay, so now that you have that over here, then we need to call our linear regression. So essentially, I always just put LR. Some people put model, whatever, like it's fine. Linear regression. And the reason why I put LR is when I'll do like a Kaggle project or just in general, if I deal with multiple models, I'd rather just have the initials. And that's just my personal preference. So we have that over here. I'm not going to put any parameters in here. We'll talk about more parameters with regressions in future videos, as well as like hyperparameter tuning and things like that. But I'm just going to put very basic, right? LR equals linear regression. Now you have to fit your data. So you put something LR.fit, and you're always going to fit your training set of data. So we're going to have X train, and you're going to have also Y train, and that now fits it. And then you get this little icon down below, which is very basic right now because there's no parameters in there. And also we're not doing any pipeline switch. Pipelines get a little bit of fun. These get expanded out quite a bit. All right. So now our data is fitted to this linear regression. We can kind of see how well it performs. And there's a few different metrics on this. Now, if you want to be super lazy and not import anything in, you can just do lr.score over here. And this is going to get you your R2 scored, or also known as R squared. Now, to get your pretty accurate version of it, you want to do your X test and then also Y test, but you can also do this on your training set. So you can see like we have 0.87 over here, which is pretty good overall. I'll show you how to do it as well. The proper way, which I personally prefer because it doesn't confuse me what the score means. And then you can see our train was a little bit higher than our test. So let's bring in a few different methods, and a few different ways we can do this is through sklearn metrics. So let's import those in. So from sklearn.metrics import, we're going to bring in mean, absolute, error. We're going to bring in mean squared error. And then just to show you that it's the same thing, we're going to do R2 score. And I also did that in this simple linear regression video. Maybe you didn't watch it, but we'll show you that over here. So, okay, now that we have all those, I'm going to build out a few more cells and let's get going. First thing that we're going to do is do a Y prediction. And this might be a little bit confusing, but just stay with me on this. We're going to do predict, and we're going to throw in our X test. All right, so let me explain why we're doing a Y prediction. You might be thinking like, what, isn't it just Y test? Well, with your model over here, you have a predict function, right? And we're throwing in our X test. So this is going to be our prediction result based off of X test. This Y prediction is going to be different than your Y test. And this is a way through over here, mean absolute error, mean squared error, and then in your R2 score, you can see how accurate your model specifically is. So you'll see this also a lot with classification problems. You'll see like a Y pred over here, and you have your model name .predict, and you throw in your X test. It threw me off a lot in the beginning when I first started machine learning, but it's been ingrained. So I just always want to call this out in videos so that way you guys can understand why this specifically is happening. So, okay, let's take a look at the first one over here, which is going to be our mean absolute error. So I'm just going to copy this because I am lazy right now as I'm recording a YouTube video, of course. And then we're going to throw our Y test in here and then throw in this Y pred, right? And then you can see that we have a score of 4.67. Now, our mean absolute error, it measures the average absolute difference between the predicted values and then also the actual values. Now, there's another way that you can do this, and it takes a look at the squared values. And I guess you should know it's a mean squared error. So this is going to be a lot higher score, right? So just copy this over here, throw this over here, and we get 33.25. And lastly, we've already done this, but just to show you for R2 score, we can throw this over here, right? Y test, Y predict, and 0.8735. And look at that. When I talked about X test and Y test, 0.8735, the same exact thing. Personally, I prefer just having R2 score over here because in my mind, it recognizes that rather than over here where score, it's kind of ambiguous. So that's my preference. If you want to just put in score and not import in R2 score, all good there. Again, just something I do. All right, lastly, we're going to be taking a look at coefficients and also your intercept. Now, since this is a multiple linear regression, you're going to have multiple coefficients associated with it, but you're still only going to have one intercept. Now, the coefficients are going to be as an array. So let's do that, right? So you can just put lr.coef like this. Unfortunately, it does have an underscore at the end, so make sure to do that. And you can see the array, right? 0.013, 0.042, 0.44, 0.05, and then 0.16. And this is associated with each of those things from above, right? We have over here hits, doubles, triples, home runs, and strikeouts, right? So just the strikeouts, for example, right? The more strikeouts a team has, the less likely they're going to win a game. And that's based off of this data over here, right? Then you have the hits data, right? The more hits someone has, you go down below, the more likely they're going to win a game. Same with double, triples, and home runs. So that's essentially how this is built out. And then let's take a look at our coefficient, right? So you can just put over here lr.intercept. And now we can just take a look at our intercept. So that's going to essentially be the lowest amount of games over here. Someone would win. And you can see 49.76, which if you go back over here and we talk about number of wins a team has, right? Started at 50 to go through 110. So essentially hit that 50 number that was at the very beginning that we called. So just kind of wrap everything up together, kind of go through this code. All right, we imported pandas, random numpy. This isn't as important. Again, just how we generated some of the data. Essentially, we used numpy over here. This was all generated through ChatGPT randoms. And then we essentially kind of cheated and kind of pre-built a linear regression with all this over here. But again, it's for the video for testing purposes. Built out our columns, right? And then we have our data, which over here, right? And our columns over here to build out a data frame. And not super important. You can start right over here. First thing we wanted to do is just take a look at an example, right? Hits versus wins, which makes sense. The more hits teams has, more likely they are to win a baseball game. And then we have strikeouts versus wins. The more strikeouts a team has, the less likely they are to win a game. Then we have over here, we're setting up DF2. We're dropping our categorical information of team. Season doesn't matter, and then losses also does not matter for this model. Our df2 has been cleaned up. Grab the columns over here. We split between our x and then also our y. So that way our x can predict the y, which is going to be our target. Then we split up our data between a training set and then also a testing set. We brought in our linear regression. We fitted this to the training data. Then we did a few different tests down below to see how accurate our model was. Mean absolute error, mean squared error, and then also our R2 score. And lastly, to see the coefficients, we just put LR coefficient and then our LR intercept at the very beginning. Hope you did learn something brand new in this video. If you did, make sure to subscribe to the channel. It's 100% for free and helps share this video to other people online that are trying to learn data science. I upload 3 videos every single week. And if you want to learn even more about Scikit-Learn, I have a full playlist right over here, which I intend to make over 50 videos just dedicated to this library. So make sure to check them out over there.